Hello! Welcome to 6.6 homework help. Alrighty, so we actually did 1 and 2 in class already, but I'm going to go ahead and go through number 2 again. So it says, what fraction of a turn does the propeller below need to turn in order to appear the very same as it does right now? Okay, that's our first question. Our second question is, how many degrees of rotation would that be? Okay. So I went ahead and just numbered all the different pieces we have, or sides, if you will. If it helps you to, I wonder if I can do that. Drawing a circle around it, I probably can't. I don't think I can. I don't think I can make this lines that, well, okay. I could do that. So 1, actually that's not a bad idea. There's 1, so that's one side. Oh, sorry. They don't like touching each other. A little bit smaller. Okay, there we go. So I can draw in lines to connect all the sides. One there. And another. Three, and another. If you don't have to do this, but if it helps you see how many sides, oh. Then do it. Connect all of them. Uh-oh. It's a little cooperating. Hold on, I got it. Okay, that's pretty good. Okay, so there are 5 different sides. 1, 2, 3, 4, 5, which is also a what? A pentagon, okay? There are 5 different sides. So this is also a pentagon. So you could actually look at your notes from today, but the fraction of a rotation, these are all the same. So if I rotate this 1/5 of the way, because there are 5 different sides, it's going to be exactly the same. Okay, just the side 5 would be where side 1 is. Side 1 would be where side 2 is. 2 would go to 3, 3 would go to 4, 4 would go to 5. Okay, they would all just shift over. Hopefully that makes sense. So your degree of rotation is 1/5. Sorry, yeah. No, yeah, not your degree of rotation, your fraction. Your fraction of a turn. Okay, if I turn this 1/5, side 5 goes to side 1, side 1 goes to side 2, side 2 goes to 3, 3 goes to 4, 4 goes to 5. Okay. Then your angle of rotation, using our formula today, we can do 360 degrees divided by the number of sides, which is 5. Okay, 360 divided by 5, 45 degrees. So that's your answer for number 2. So number 1, number 2, and number 3 are all very similar. Number 3, you just have a lot of sides, okay? So make sure you're careful when you're counting the sides. Let's keep on going. Okay, number 4, draw the lines of symmetry for each regular polygon. Keyword here, regular, okay? Regular. Again, let me highlight it. I don't really understand why I can highlight sometimes and other times I cannot. Okay, I'll underline it. Keyword, regular. Okay, that means all the sides and all the angles are equal. Fill in the table, including an expression. Okay, this I gave you in class, the last part. But anyways, so we have a triangle. So remember, we'll see how they write it in the book. Oh, they just do n equals n. Okay, so number of sides equals number of lines of symmetry. So number of sides, however many sides are, that's how many lines of symmetry there are. If you want to use a different variable, you can. So my triangle has 3 sides, so I'm going to have 3 lines of symmetry. My square has 4 sides, I'm going to have 4 lines of symmetry. Okay, and so on and so forth. Then you're supposed to draw them in. Okay, we did triangle, we've done the square. We kind of did the pentagon. Let me do the hexagon. Yeah, I think so. Okay, let me get my little line. So what did I say we were going to do? Oh, actually, sorry, we didn't ever finish the pentagon. So the pentagon, okay, is I can go from a vertex, oops, to the middle of the opposite side. It's approximately right there. That didn't look very good. Let me shift it over just a little bit, see if it looks better. Hold on a second, that doesn't look right at all. Let me pause you for a second. Oh, my bad, I may have hit the wrong side. Okay, so let me get my line again. So from the vertex to the middle of the opposite side. Oh, this is a hexagon. Oh my, this is not working. That's why. Oh dear, oh dear, oh dear, oh dear, oh dear. Why isn't this working? Okay, so from the vertex, there we go, to the opposite side. There it is. Okay. All right, so there's 1. So you would have to draw in all 5 of them. Oops. So we're going to go from the vertex. Oops. From the vertex to the middle of the opposite side. Okay, so there's another one. From the vertex. Okay, and they're all crossing in the center. They're all crossing in the center. So that's your center of rotation, right? We're rotating around the middle. We are rotating our shapes around the middle when we rotate them. We do another one. Oops. Where's another vertex? Oh, here it is. Vertex to the opposite side. To the middle of the opposite side. And then the last one. Vertex to the opposite side. There. Okay. So there's your pentagon. There are your lines of symmetry. There are 5 of them. Okay. Now, let's try the hexagon. So obviously, since I tried it and it did not work, going from the vertex to the side, that doesn't work, right? Because I tried it like twice. Like you can look at that. This side is clearly bigger than this side. So that is not one of them. Let me delete it. Okay. So you're going to have to experiment a little bit with your hexagon. Where is the first line of symmetry? Okay. Probably most of you are going to say, well, fold it in half, Miss Bailey. Okay. So there's 1. Right? If I fold over that line, it folds directly onto itself. All right. Where's another one? I need you to be pausing me and trying these by yourself, right? Okay. Well, do I have my line? Oh, I do. If you're going from the middle of this flat side to the middle of this flat side, remember you can rotate it. So that means I can go from the middle of every side, so like the middle of this side, to the middle of the opposite side. Okay. From the middle of this side to the middle of that side. Okay. That's only 3. We need 3 more. So how else? I wonder if I should get rid of these. Let me get rid of these because it makes it kind of hard to see. Okay. What else? Okay, let's try. There you go. That's another way you can cut it in half, right? Okay, so then remember you can rotate it. So if I go from this vertex to the opposite vertex, I'm going from this vertex to the opposite vertex. So I can do that with all my vertices. So if I start here, I'm going to go to the opposite vertex. Boop. These are also called what? What's the vocabulary word for these lines that I'm drawing in? The lines of symmetry, they're also the diagonals. Diagonals go from the opposite vertex to the opposite vertex. Boom. Okay. So there are my other 3 lines of symmetry for a hexagon. Okay. Moving on. Now, number 5, you're going to draw all of the diagonals in each regular polygon. Fill in the table and find a pattern. Is it linear, exponential, or neither? How do you know? Okay, so this one's going to be hard, where you try and find an expression, so I'll be pretty impressed. But I want you to try it. Okay, so diagonals. Diagonals just go from the opposite vertex to the opposite vertex. So if you're looking at a triangle, here's a vertex, and then it doesn't have an opposite vertex. Uh-oh. Okay, so triangles do not have any diagonals. Vertex to vertex, that's not a diagonal, that's part of the shape. Vertex to vertex, that's not a diagonal, that's part of the shape. So triangles do not have any, do not have any diagonals. None. Okay. Square, we've done before. I guess I can. Opposite vertex to opposite vertex. Okay. Another line, opposite vertex to, oh, that wasn't quite on there, to opposite vertex. All right. So squares have 2. Pentagon. Okay, opposite vertex to opposite vertex. Here to here. And then, actually, our definition, do I have written on here? Oh, no, this is just the homework. Okay, let me rewrite it. Hold on. I shouldn't just be saying opposite vertex, opposite vertex. It is. Let me give you the exact definition. Okay, for a diagonal of polygon. Any line segment that connects consecutive. So it's not just opposite to opposite. Non-consecutive, that means they're not next to each other. That means they're not next to each other. So like this vertex and this vertex are next to each other, so there's no diagonal between them. This vertex and this vertex are right next to each other, so there's no diagonal between them. But I can go, did I grab it? I think I did. From here, I can't go here, they're next to each other, but I can go all the way down here. And then, oh, it's not gonna let me. Oh, maybe it will. No, it won't. Oh, I might have to draw on my last one. Hold on. So it's not gonna be as straight. You could also go from here to there. Oh, that wasn't actually that bad. Okay. As long as they're not next to each other. So that is 1, 2, 3, 4. 4, I believe. Let me check my answer before I write it down for you. Oh, it's 5. 1, 2, 3, 4. I'm missing one. Okay, we go from there to there. Connect those two. 1. Okay, 1, 2, 3, 4. Okay, 1, 2. It's gonna bother me. Okay, this one can't go there, but it can go up to there. So that's 2, 3. Okay, and then I can also go from here. Oh, I see it. Okay, never mind. From here, you draw it in again from here to here, and then my last one, sorry about my wonky line. And I have another one. Oh, sorry. My last one, goodness. These two are not right next to each other, so I can also connect those two. Just want my pencil. Just want my pencil. Thanks. There. To there. Okay, there we go. So that does make 5. Whew. 5. These are kind of hard. I'll try one more. Actually, that's going to get real messy. If I were you, I would draw these shapes bigger on a piece of paper because it's going to make them all easier to see. So you have a triangle, square, pentagon, hexagon, heptagon, so 7 sides, and then an octagon. So as long as the vertices are not next to each other, you can connect them with a line. So I'll start the next one, but I won't do all of it. How about that? So like from this vertex, it cannot go to there, and it cannot go to there because they're next to each other. But it can go here, and it can go I'm going to have to use my pencil. It can go there, and it can go to this one because they're not next to each other. And it can go to that one because they're not next to each other. Okay. So move on to your next one. Where can this guy go to? It can't go here because they're next to each other, and it can't go here because they're next to each other. But it can go to the other 3. Okay. Scrolling down. Number 6, find the angles of rotation that will carry the 12-sided polygon onto itself. You can use our formula from today, which was 360 divided by n, where n equals number of sides. So for this one, 360 degrees divided by the number of sides, 12. It tells us. You can also count them. There are 12 sides. 360 divided by 12. 30 degrees. So then you would just write them, you could just write them all out. So 30, and then your multiples of 30. So you're adding 30 each time. 60, and then plus another 30, 90, oops, 120, 150, 80, 10. I'm adding 30 every time. I'm going to mess it up. 240, 70. Oh, no, we're good. 100. I'm adding 30 each time, 330, and then 360. So those are all my angles of rotation for this 12-sided polygon. Number 7, what are the angles of rotation for a 20-gon? So a 20-sided polygon. So we use the formula again, and then how many lines of symmetry, lines of reflection will it have? Well, remember, number of sides equals lines of symmetry. So if I have 20 sides, then I have 20 lines of symmetry. All right, 9 through 14. Yes, 9 through 14, you are reflecting already. Go ahead and do number 9. So reflect point A over the line of reflection and label the image A prime. Okay. Whale. Line of reflection and the line that's going to connect A to A prime, they are going to be perpendicular. Okay, so we're going to find the slope of this line. So let's find the slope of this line. Let me start here. You can start at any point on the line. I'll start at this one. So I'm going to go, it looks like I go up 1, 2, 3, and then over 1. Do I do it again? Let's see, 1, 2, 3, over 1. Yes, I do. All right, so my slope is 3 over 1, right? Up 3 over 1, up 3 over 1, up 3 over 1. So then it's going to be perpendicular, so the opposite reciprocal slope. So new slope is going to be, flip it, so you get one, oops, I hit something weird. You get 1/3, and then make a negative. So you get negative 1/3. Okay, so that's down 1 over 3, but I need to go the other way. So I'm going to go up 1 to the left 3. 1, 2, 3. And then up 1 to the left 3. 1, 2, 3. You draw a line, connect my little points. See if I can do it evenly. Almost. There we go. Okay, and then they have to be the same distance away. So this guy is 1, 2, 3. This guy is also 1, 2, 3. So they are the same distance. So this would be your A prime. It's not going to put A1. A1 sauce. Ha. Okay. So then number 10 is very similar to that. Okay, for number 11 through 14. Oh, actually, okay. No, okay. 11 and 12, you're reflecting shapes over the line. And then 13 and 14, you're doing the opposite. You're drawing in the line of reflection. So let's look at, doesn't matter, I guess, number 12. Okay. Well, let's see. From my line, A is 1, 2, 3, 4 over 4. 1, 2, 3, 4 over 4. Sorry, up 4 over 4. Up 4 over 4. So if I were to reflect A over this line, just do the opposite thing. 1, 2, 3, 4. 1, 2, 3, 4. So instead of up 4 over 4, I went, oh, sorry, I shouldn't say over. Up 4 and right 4. Oops, right 4. So then I'm going down 4 and left 4. So I'm doing the opposite thing. You also could find the slope of your line of reflection. Let's see. I'm going, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down. Okay. So my slope of my line of reflection is slope negative 1 over 1. So then slope of my new line would be positive 1 over 1. So I'll go down 1 over 1, 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 down. And I'll get to the same point. Okay. Then you could do the same process for B, C, and D, or you can just do it based on how far away they are from A. So let's see if I go. So from A, B should be 1, 2, 3 over 1. Okay. Oh, sorry, 1 second. I have to pause you. Hold on. Hold on, hold on, hold on. Sorry about that. Anyways, okay, so this is A. I meant to label that, or A1. It's A1. Okay. For B, I'm just going to do the same thing. So my slope is of this line of reflection is negative 1 over 1. We already figured that out. So then I'm using the slope 1 over 1. Okay. But up 1 over 1 is going the wrong way. So I'm going to go down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Yeah, I'll put little dots down. Okay, down 1, left 1, 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 down 1, left 1. It's probably as far as I need to go, but you can keep going if you want. Let me draw a line. Oops, I am not in a good spot. There we go. Line, 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 line. Ooh, there. Let's see if I connect those with a straight line. Almost. Oh, wonderful line. Just there we go. Okay, and then just make sure they're the same distance away from this line. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so right here. No, I really? Usually it lets me pencil over my lines. Can I not? Okay, we're gonna get rid of the line then. Bye. All right, and it was right here. Okay, so that would be your B1 or your B prime. Let me see a little bit. Okay, that got a little away from me, but that would be your B prime. Okay, so then you do the same thing with C and D. Actually, I'll go ahead and do C. So for C, just use the same slope. So down 1 over 1. Stop it. I'm going to down 1 over 1. Oh, look, we're on A. Stop. Just let me use my pencil. Oh, my gosh. You down 1 over 1. 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 Down 1 over 1, down 1 over 1. Oh, look, we're on A. Down 1 over 1, down 1 over 1. I don't know how far I have to go. Down 1 over 1. Okay. Go one more. Down 1 over 1. Headaches. Okay. So then, once again, make sure they're the same distance away. So C is 1, 2, 3, 4, 5, 6. So we have to be 6 away. 1, 2, 3, 4, 5, 6. Okay, so this should be C. Okay. You could also be doing this. Oh, I didn't mark C. Sorry, I got distracted. 1, 2, 3, 4, 5, 6. So right here. That's C, or C prime. You could also be doing this by, once I get A, finding how far away these are all from A. But yeah, and then you do the same thing with D. Here, I'll start connecting my shape. So I have A to B. Maybe I won't, not if it won't let me. Nope, nope, okay, fine. So you connect all your new points with lines to make the same shape. Technology is not with me today. Okay. 13 and 14, I would just pick a point, so like x and x prime, or y and y prime, it doesn't matter. Okay, figure out the slope, and then the line is going to be perpendicular to that. Okay, I'll just, or do I want to do y? It probably doesn't matter. I'll do x prime. Okay, so then we have to figure out the slope of that line. It looks like it is going down 1 over 1, down 1 over 1, down 1. Okay, so my slope is -1 over 1. Oops, over 1. Down 1 to the right 1. So then my new slope is going to be opposite of that. Opposite reciprocal. So technically I would flip it. It'd be 1 over -1, but then I change the sign. So find your middle point, which looks like it's like right here. Right in the middle. Boop. Boop. And then you would be going up 1 over 1. Up 1 over 1. 1 over 1. Down 1 over 1. Down 1. Oh, that wasn't quite right. Down 1 over 1. Down 1 over 1. That also wasn't quite right. Let's take that one off. There we go. Okay. You don't have to write, nope, you don't have to write the equation for it. So just draw our line in. Here it is. There. So you just have to pick either x and x prime. You could have done y and y prime, z and z prime, doesn't matter. So you're going to do the same thing for 14. Whew. Okay, and we're done. Thank goodness.